This is Unit 11, Lesson 12. We are graphing quadratic inequalities. And your objective is right here, so let's go ahead and get started. Alright, all your steps are right here, and I'm going to go ahead and read through these real fast with you. Sketching a quadratic inequality is exactly like sketching an equation, okay, and an inequality combined. So when we graphed our parabolas, that's what kind of shape we're going to end up with. We're going to go through all those steps, okay, that we did for graphing our parabola. But we're going to combine that with the knowledge that we had of graphing inequalities, where we had to think about, is it a solid or a dashed line, okay, and did we have to shade a certain way. So, step 1 is to sketch the graph of the quadratic equation that corresponds to the inequality. So we're going to pretend like, instead of the inequality signs, it's an equal sign. So we're going to find the vertex, and we're going to do a table of values and all that stuff, and we're going to make our parabola. But we have to decide if our parabola is going to be dashed or solid. And again, it's dashed when the sign is greater than or less than, and it's solid when the sign is greater than or equal to or less than or equal to. Okay, so again, find the vertex, find your table of values, and we're going to plot the points, and it should make a curve. Okay, and then we're just going to decide, does our curve need to be dashed or solid? After that, the parabola separates the coordinate plane into two regions, inside the parabola and outside the parabola. Okay, so we're going to have something, whoops, sorry, I like my thicker pen here. We're going to have something that looks like this, okay? And it might be a dashed parabola. And the parabola splits it into two regions, inside and outside. So this is our parabola right here. Okay, we have to decide, are we going to shade in the parabola right here or out around the parabola out here? Okay, and to do that, we're going to test a point that's not on the parabola. So again, I'll recommend 0, 0 if 0, 0 is not on your parabola. Otherwise, we could pick any one of these points in here or out here. Okay, and test it. If the point is a solution, okay, so let's say that I pick this point right in here, and that is a solution, then I'm going to shade inside the parabola in the region it's in. And if it does not work, then I'm going to shade out here, out around the parabola. Okay? So that's what we're talking about. We're sketching the graph of quadratic inequalities. Alright, and I've got one example for you, so let's go ahead and do it. Okay, first thing, here's our quadratic inequality. Alright, so we got 3 is less than x squared minus 3x. Again, our first thing we need to do is get this into standard form. Okay, so I'm not going to move my x's around, but I'm going to go ahead and subtract 3 from both sides. And I get 0 is less than x squared minus 3x minus 3. And now again, for graphing purposes, we put this 0, we replace it with y. So my inequality is going to be y is less than x squared, and we're going to make an addition, plus negative 3x plus negative 3. Okay? The first thing I want to decide, this right here means, is it solid or dashed? Well, I've got a less than sign, so it's going to be dashed. Okay, so we have to keep that in mind so that when we actually plot our points out, we know to connect them with dashes and not a solid curve. Which way does it open? Well, my A, first let's go ahead and pick out our A, B, and C. Our A is 1, our B is negative 3, and our C is negative 3. Okay? Well, since our A is positive, that means it opens upward. So we're going to decide that as well. So it's going to be a dashed parabola opening up. Then we need to find the vertex. And again, the vertex, the x-coordinate, is the opposite of B over 2A. So in this case, the opposite of B, the opposite of negative 3, is positive 3 over 2 times 1, which is 2. So the x-coordinate of the vertex is 3/2. So now I'm going to plug that in to figure out what the y-coordinate is. Okay. Now again, when we are graphing this, we're going to pretend like this is an equal sign. Okay. The only thing that we'll need to pay attention to the inequality for is it solid or dashed, and then which way we're going to have to shade at the end. So right now we're going to pretend like this is an equal sign to solve it. So I'm going to say that y equals, and it's 3/2 squared plus negative 3 times 3 halves. I'm going to go ahead and put this over 1 since we'll have to multiply it, plus negative 3. Well, 3 halves squared, that's 9 fourths, plus negative 3 times negative 3 halves is negative 9 halves, plus negative 3. Alright, so we've got 9 fourths plus negative 9 halves. Well, that's 9 fourths plus negative 18 fourths. And then negative 3 is negative 12 fourths. So I've got negative 18 plus negative 12 is negative 30, plus 9 is negative 21 fourths. Okay? Or that's negative 5 and 1 fourths for the y value. So my vertex is 3 halves and negative 5 and 1 fourth. Okay? On the next slide, I've already made the table of values for us because we know how to go about making a table of values. We're going to pick 3 points that are lower than this. So I would start with 1, and then 0, and then negative 1. And then going up, okay, I would start with a number that's equal. Okay, so my x value is 3 halves here. That's 1.5. Okay, so I'm going to go to 1. And since 1 is a half away from 3 halves, I'm going to go a half upward as well, which is 2 on the other side. And then again, I can count 0, negative 1, and 3 and 4 on the bottom for my x's. And I've done all that on the next slide already. Okay, so let's go ahead and look at what this is going to look like when we graph it. Alright, so I've got all my ordered pairs right here from the table of values. So I went ahead and did all that work for you. Okay, and I trust you can do it. Now I'm sorry here, this axis got a little messed up when I transferred this file. So each of these is a line off. So every 2 lines should be 1. So here's 1, here's 2, here's 3, and so on. So I'm going to go ahead and just redraw those in red. There's 1, 2, 3, 4, 5, and then negative 1, negative 2, negative 3, negative 4, and negative 5. Okay? So I'm going to plot the points. Negative 1, 1 goes here. 0, negative 3 ends up here. And again, sorry about that. 1, negative 5 ends up here. Now my vertex is going to be slightly off the grid here. That's okay since it's so close. It's at 1.5 and negative 5 and 1 fourth. Okay, and then I got 2, negative 5, and 3 and negative 3, and 4 and 1. And with that vertex, I would caution you to try not to do that and get it off the grid. But since, again, this one's so close to where it ends anyway, it's not too big of a deal. Now remember, this was a dashed parabola opening upward, so I'm just going to go ahead and draw in some dashes here. Okay? Again, the dashes are kind of an inexact science, but that's alright. Now I have to pick a test point, and I have to test and see if I'm going to shade inside this parabola in here, or outside the parabola, out around all this stuff. Okay? So I'm going to pick a test point, and again, like 2, 0 would be easy, 1, 0 would be easy, but if 0, 0 is available, that's always the easiest. Okay? So I'm going to ask myself, is 0 less than 0 squared plus negative 3 times 0 plus negative 3? Okay? So is 0 less than 0 squared is 0 plus negative 3 times 0 is 0 plus negative 3. Okay? Is that true? So again, my test point is 0, 0. And I'm writing that down just so I remember what it was. Okay? Well, 0 is not less than negative 3. So 0, 0 is not a solution. That means I need to shade out around out here. Okay, so my shading goes out here to show that points out here are solutions. Okay, and you don't have to color it all the way in. Okay, just enough so that we can see what the solutions are. That the solution region is out around the outside of the parabola. Okay, so if I picked any one of those points, like let's say 5, 0, then that should work out. Because 5 squared is 25, negative 3 times 5 is negative 15, 25 plus negative 15 is 10, plus negative 3 is 7, and 0 is less than 7, so it works out. Okay, so again, these are the solutions to this inequality. All these points out here are solutions. Alright, that's your lesson on graphing quadratic inequalities. Again, shouldn't be too bad as long as you know how to graph quadratic equations with the vertex and the table values. And then again, test a point and figure out which way to shade. Don't forget to pay attention to, are we solid or dashed parabolas, and what way we need to have shaded. Okay, that's your lesson. Happy homeworking.